A language model alone is stateless. You ask it something, it answers. The next call, it remembers nothing. It has no way to run code, access the internet, or write a file. It can't take action, it can only produce text. These aren't flaws to fix, they are architectural limits. The language model is the reasoning engine, not the whole agent. 4 components have to be added: a perception module to process inputs, a memory system to maintain state, a reasoning core to plan, and an action layer to execute. Remove any one of them, and the system fails in a specific, predictable way. Think of a surgeon operating. Their eyes and tactile feedback are perception, converting the real world into structured information. Their surgical training is in Waite's memory, expertise baked in during years of practice. The patient notes on the table are in context memory, the working facts for this specific operation. And the scalpel is action, the ability to actually do something in the world. 4 components. Each one can be upgraded independently. The perception module can gain vision support. The reasoning core can be swapped for a stronger model, but each component boundary is also a failure point. 4 chances for something to go wrong. The perception module is the agent's interface with reality. Raw inputs arrive: a user message, an API JSON response, a screenshot, a PDF document, and the perception module converts them into structured tokens the LLM can process. This step is where most production agent failures begin. Malformed JSON from a third-party API, a PDF with inconsistent encoding, a web page with mixed language content. Any of these can corrupt the input before the reasoning engine ever sees it. Engineers who have shipped production agents say the same thing. Spend 40% of your build time on input parsing and validation. The reasoning core is the LLM, and the most important thing to understand about it is its context window, the working memory it can read from and write to during a single call. GPT-4 holds 128,000 tokens, Claude 3. 5 Sonnet holds 200,000, Gemini 1. 5 Pro holds 2 million. These numbers sound large until you consider context rot. Model accuracy degrades measurably before reaching the advertised limit. A 200,000 token model becomes unreliable around 130,000 tokens in practice. The context window is not free memory. Every token you push in costs money on every future call, because input tokens are billed on every loop iteration. Memory in agents has 4 distinct layers, each with different speed, capacity, and cost. In context memory is the current conversation, instantly available, precise, but limited to the window size. External memory, vector databases like Pinecone or Qdrant, stores facts across sessions. You query it with natural language and get back relevant documents in 4 to 16 milliseconds. In Waite's memory is knowledge baked into the model during training, permanent but expensive to update. And KV cache stores previously computed attention states, so the model doesn't reprocess the same system prompt on every call, reducing costs by 60 to 80%. The action module is the most powerful and the most dangerous component. It's where the agent calls APIs, runs code, writes files, sends messages. Here's the rule every production engineer learns the hard way: give agents read-only tools by default. Require explicit human approval before any destructive action. A tool call that returns an error doesn't stop the agent. It generates a new observation. The agent tries again, and your bill doubles. At 10 steps with tool retries, a single bad API call cascades into 100 tokens of garbage context, poisoning every subsequent decision. The chain is only as reliable as its weakest component. Every time you design an agent component, ask 3 questions. What is the data format coming in? What can go wrong at this step? Does a failure here propagate silently to the next component? A 99% accurate perception module, combined with a 95% accurate memory retrieval, and a 97% accurate reasoning step gives you 91% per step reliability. At 10 steps, that's 39% end-to-end success. The surgeon metaphor holds. Perception sees, memory recalls, reasoning plans, action executes. Each instrument must work. Every chain is exactly as strong as its weakest link. Pause here. Study the interface between every component.